In California, dangerous waves are creating havoc along the Pacific coast to end the year. Powerful storms are churning up ocean water, bringing flooding and damaging structures near the water.
Oh, shit! Oh, no!
The U.S. is facing deadly weather attacks, as recent news has revealed a water disaster in California. Massive waves and powerful flooding hit seawalls and the coast in California, destroying beachfront buildings and leaving many people injured. Pictures and videos of the ruins the floods have caused are all over social media, inciting deep conversations and heightening worry. Amidst this sudden catastrophe, everyone is left wondering why this happened. What caused this disaster that lasted for several days, and what could it mean? Prepare to delve into everything about the treacherous waves challenging California's calm waters and threatening people's lives and properties. Massive waves have recently unleashed shocking chaos along California's coastal regions, creating a tumultuous scene that lasted for days. These extraordinary conditions have resulted in water rescues, the sweeping away of cars, and injuries to fascinated onlookers. The surf, reaching heights often exceeding 20 feet, led to the closure of beaches across the California coast. The forceful waves have not only affected the recreational aspects of these coastal areas, but also caused significant damage, inundating streets, homes, and businesses.
Waves poured over walls, causing flooding and damage to homes. The Ventura County Fire Department.
The impact has been particularly severe in Ventura County, where waves breached seawalls, carrying parked cars downstream into significant intersections. The aftermath has been challenging for first responders, facing obstacles created by the displaced vehicles. Fire Captain Brian McGrath, speaking to CNN affiliate TNLA, highlighted the extent of the damage, with flooding in a local hotel causing havoc in all of its ground floor rooms. The relentless assault of high water and risky rip currents has besieged a vast stretch of the West Coast, ranging from Southern California to Oregon. These adverse conditions are attributed to a series of robust storms making landfall, originating from the formidable Pacific Ocean. Coastal communities are grappling with the aftermath, emphasizing the vulnerability of these areas to the powerful forces of nature. Although the threat of hazards was anticipated to diminish for residents in Northern California, the coastal regions of Central and Southern California continue to face the relentless onslaught of extreme surf. Predictions suggest that in some impacted areas, the waves could reach a towering height of about 25 feet. However, the severity increases significantly in California's Bay Area, where certain waves may surge to an astonishing 40 feet, comparable to the size of a telephone pole. Additional waves are expected to range between 28 to 33 feet, contributing to the hazardous conditions along the coastline. The coastal regions of southern Oregon are not exempt from the turbulent weather, as they too are anticipated to experience robust surf and high winds. High surf warnings have been issued for the affected areas, remaining in effect through Saturday morning, as waves between 20 and 25 feet are projected. The spectacle of these powerful waves has captivated curious onlookers and adventurous surfers, drawn to the intriguing display of nature's force. Keep watching to know the extent of the disaster. Local authorities and officials urge individuals to exercise caution and avoid venturing into the water or visiting the beaches. The prevailing conditions pose a significant risk to life, emphasizing the need for adherence to safety advisories. While the allure of massive waves may be tempting, the potential dangers associated with such conditions highlight the importance of prioritizing personal safety and heeding the guidance provided by local authorities. As the coastal areas grapple with the ongoing impact of these extreme surf conditions, the overarching concern for public safety remains paramount. The delicate balance between the natural fascination with powerful waves and the imperative to prioritize well-being reflects the ongoing challenge of managing the intersection between human curiosity and the unpredictable forces of nature. The National Weather Service in Los Angeles has issued a stern warning regarding the safety of beaches, piers, and vulnerable harbors. According to their advisory, these areas should not be considered safe due to the heightened risk posed by extreme surf conditions. The gravity of the situation prompted Ventura County officials to take decisive action by closing all beaches through New Year's Eve. This proactive measure responds to the looming threat of waves reaching an imposing height of 15 to 20 feet, expected to pound the coastline until Saturday evening relentlessly. The closure of beaches in Ventura County is a prudent step to mitigate potential hazards associated with the substantial waves. The decision is a commitment to public safety, recognizing the significant risks posed by the formidable surf conditions. The closure extends to popular beach destinations in Hermosa, Manhattan, and Palos Verdes, which are anticipated to experience the most extreme surf on Saturday, putting them at heightened risk for significant coastal flooding. In light of the escalating conditions, an evacuation warning has been issued for residents in specific areas around the Pacific Coast Highway in Ventura County. This strategic move aims to safeguard individuals residing in vulnerable zones directly impacted by the high surf. The fire department, tasked with ensuring the community's well-being, announced this evacuation warning as part of their proactive efforts to address the evolving situation. The dynamic nature of the ocean, coupled with powerful weather patterns, shows the need for vigilance and preparedness in coastal communities. The decision to close beaches and issue evacuation warnings reflects a collective commitment to minimizing risks and prioritizing the safety of residents and visitors. As the region braces for the impact of substantial waves, these measures serve as a crucial reminder of the imperative to remain attentive to weather advisories and adhere to official guidance for public safety. But that's not all. The situation along the California coast witnessed a significant development on Saturday afternoon as the earlier warnings were lifted. The vigilant efforts of Ventura first responders were evident, with approximately 10 people successfully rescued on the second day of the flood. These dedicated responders played a crucial role in ensuring the safety of individuals facing challenges amid the tumultuous conditions. In a testament to the collaborative spirit during this challenging time, 2 beachgoers emerged as unsung heroes by aiding in the rescue efforts. Their quick and selfless actions included pulling a struggling lifeguard out of the water. This lifeguard, having ventured into the ocean to rescue a person near the pier, found themselves in a dangerous situation. The assistance provided by the vigilant beachgoers played a pivotal role in ensuring the lifeguard's safe return to shore. The challenges faced during the first round of severe surf on the initial day of the flood highlighted the unpredictable nature of the ocean's response to powerful weather patterns. A wave of considerable force swept nearly 20 people away, striking a beach barrier lined with onlookers in Ventura Beach's Pierpont area. The intensity of the impact led to 8 individuals sustaining injuries, necessitating their transportation to the hospital for medical attention. Colin Hogg's video captures a harrowing scene as people desperately navigate the chaos, attempting to escape the towering wave crashing over the barrier. In his account, he describes the experience as nothing short of terrifying and apocalyptic, emphasizing the sheer force and urgency of the situation. The footage illustrates the rapid advance of seawater, sweeping individuals off their feet and creating a scene of pandemonium. Cars, in an attempt to evade the onslaught, were battered by the relentless waves. As the towering wave crashed over the barrier, witnesses reported a frenzied atmosphere with people yelling and screaming, driven by the instinct to run as fast as possible from the advancing danger. The urgency of the situation is palpable, and Hogg's video provides a vivid account of the challenges faced by those caught amid this natural upheaval. This extreme weather event was fueled by storms that not only generated massive waves, but also brought rain and wind to California, marking the 3rd consecutive day of flooding. The impact of the storms extended beyond the coastal areas, with rain and wind affecting various regions of the state. As morning arrived, the rain shifted inland and swept across Southern California, gradually weakening over the Rocky Mountains in the subsequent days. Inland areas experienced the consequences of the weather system, with a wintry mix forecast for central and eastern California. Projections indicate the potential for significant snowfall, exceeding a foot in high-elevation crests and peaks, while lower-elevation mountain areas may see between 6 to 12 inches. This multifaceted weather phenomenon underscores the diverse challenges storms pose, encompassing coastal flooding, heavy rainfall, and mountainous snowfall, contributing to an impactful meteorological event. Before we dive deeper, let's rewind for a moment. What really caused the massive waves in California? Richard Thompson, a seasoned meteorologist with the National Weather Service in Los Angeles, shed light on the factors intensifying the coastal challenges in California. According to Thompson, the current predicament results from a confluence of elements, primarily the adverse interplay between a storm and elevated tides. He emphasizes that this combination significantly amplifies the impact on the coastal regions. The storm, positioned hundreds of miles from San Luis Obispo County's coastline, wields formidable hurricane-force winds. These powerful winds are instrumental in propelling ocean water forcefully toward California. The consequence is a colossal swell and the emergence of exceptionally high surf along the shoreline. The magnitude of the waves is notably pronounced due to the storm's influence on redirecting ocean water, creating a situation where waves crash closer to the shore than under typical circumstances. Adding to the seriousness of the situation is a high tide measuring approximately 6.5 feet. This elevated tide level further contributes to the proximity of the crashing waves, heightening the risk and impact along the coast. The Weather Service, recognizing the gravity of these conditions, took decisive action by issuing both a high surf warning and a coastal flooding warning. These warnings, encompassing areas of the Central Coast, were set to be in effect from Thursday through Saturday evening. The advisory issued by the Weather Service is a crucial component of public safety measures, urging people to exercise caution and avoid beaches during this period of heightened risk. The breaking waves, forecasted to reach impressive heights between 15 to 25 feet, necessitate a proactive approach to safeguard individuals from the dangers of the surging surf. As communities along the Central Coast face these challenging conditions, the insights provided by meteorologist Richard Thompson stress meteorological elements contributing to the current scenario. The storm's influence on ocean dynamics and the simultaneous occurrence of high tides prove the strange nature of coastal weather patterns, demanding a vigilant and responsive approach to ensure the safety of residents and visitors alike. Stick around for a rare event that relates to the disaster. The current surge in surf conditions along California's coast may be influenced by an additional factor: hot sea surface temperatures in the equatorial Pacific Ocean. This phenomenon indicates a potentially significant El Niño event, one that meteorologists are characterizing as historically strong. The impact of this warming trend in the Pacific Ocean has far-reaching consequences, creating conditions ripe for the development of powerful storms. El Niño events are known for their association with increased storm activity, and the current warmth in the equatorial Pacific has heightened the likelihood of robust storm systems. The warm ocean currents act as a catalyst, contributing to the formation of intense storms that have the potential to bring substantial rainfall to California. This raises the prospect of a rainy winter for the state, with implications for water resources and overall weather. Note that this El Niño event has the presence of oceanic downwelling Kelvin waves. These waves result from the thick, warm layer of the Pacific Ocean shifting eastward. The movement creates an expansive, ocean-wide wave that traverses the vast expanse of the Pacific, taking 2 to 3 months to reach the shores of California. As meteorologists track the development of this El Niño event and its associated phenomena, there is an anticipation of heightened storm activity and increased precipitation. The potential for a rainy winter brings opportunities and challenges, with considerations for water resources, flooding risks, and overall resilience to changing weather patterns. Kelvin waves introduce a distinctive aspect to our understanding of oceanic changes, setting them apart from the familiar crashing waves that grace our shores. Unlike the brisk and visually striking waves we commonly witness, Kelvin waves exhibit a notably gradual movement, ambling along at just a few meters per second. David DeWitt, the director of the National Oceanic and Atmospheric Administration's Climate Prediction Center, elucidates this characteristic in an emailed statement to the Tribune. DeWitt emphasizes that Kelvin waves, despite their unhurried pace, possess a noteworthy capacity to induce changes in sea level, but what distinguishes them further is the lasting nature of this effect. The influence of Kelvin waves extends over several months due to their leisurely progression. This prolonged impact on sea level reflects the unhurried nature of these waves, allowing them to impart alterations that endure for a substantial duration. Not many know about what we're about to reveal to you. A critical feature of Kelvin waves in this case is their ability to reach heightened amplitudes when encountering shallower waters. As these waves navigate into less profound expanses, their energy intensifies, increasing amplitude. This phenomenon illustrates how the characteristics of Kelvin waves evolve as they interact with varying depths. Basically, Kelvin waves contribute a unique dimension to the oceanic phenomena. Their unhurried journey and prolonged effects on sea level highlight the intricacies of these waves, offering a glimpse into the subtle yet impactful forces that shape our coastal environments. Understanding these distinctions enriches our comprehension of oceanic processes and their broader implications for the relationship between the sea and the shore. Gary Griggs, a seasoned professor of earth sciences at UC Santa Cruz, provides valuable insights into what happens during El Niño events. According to Griggs, these conditions pose a triple threat, combining the forces of a formidable storm, hurricane-strength winds generating substantial waves, and elevated winter tides. The convergence of these elements creates a potent recipe for potential damage along the California coast. Griggs shed light on the multifaceted nature of this threat, emphasizing the interplay of factors contributing to the heightened risk. The enormous storm, characterized by hurricane-force winds, acts as a catalyst, stirring up waves of considerable magnitude. These waves, driven by the powerful winds, add complexity to the coastal conditions. To better understand the situation, we need to explore what possibly triggers angry waves. That brings us to the question, how did the dangerous waves of the ocean form? Floods, in the past 100 years alone, have caused the loss of millions of lives, surpassing any other weather-related event. Events like Hurricane Katrina in New Orleans and the 2022 monsoons in Pakistan highlight the widespread devastation floods can bring. But what really is a flood? You're about to find out. The sun's heat makes winds. It shines more on the middle part of Earth than on the parts farther north or south, creating a temperature difference across the planet. In warmer spots, the hot air rises, allowing cooler air to come down. In cooler places, the cold air sinks, pulling down warmer air into the space. The Earth's spin splits this process, creating many smaller cycles of air movement worldwide. These air movements also guide the cycle of Earth's water. When the sun warms the oceans, the water on the ocean surface turns into invisible water vapor in the air, like steam rising from a hot drink. The sun also warms up this air, making it grow into the sky with the help of the wind. As this watery air rises, it cools down, and the water vapor turns back into tiny drops of liquid water, or ice crystals. These little drops gather together to create what we see as clouds. If a cloud moves to a colder place, more water might join these drops. When there's enough water, the drops become heavy and fall from the sky as rain, snow, sleet, or hail. We call this precipitation. Some of this water is stored underground, like in big hidden pools, but most flows in rivers and streams that eventually reach the oceans. This completes the journey, bringing the water back to where it started. The cycle of water, moving from the sea to the air, forming clouds, and returning as precipitation, only to repeat the process repeatedly. Usually, the way the wind moves in the sky remains relatively consistent. This leads to specific locations generally experiencing similar weather patterns each year. However, with the impacts of climate change, we've seen a shift towards more extreme and less predictable weather conditions. As time passes, rivers and streams naturally develop, with their sizes aligning with the typical water levels in the region. Yet when there's an excess of water, these watercourses can't contain it all, resulting in overflow. The surplus water then extends over the adjacent land, causing a flood. In simpler terms, a flood occurs when there's an unusual water accumulation in a particular land area. While heavy rain from a series of storms is the most common cause of floods, there can be other reasons too. Let's find out. Flooding often occurs when a region experiences an unusually high frequency of rainstorms within a relatively short time. This inundation happens as rivers and streams, typically responsible for channeling water to the ocean, are inundated beyond their capacity. The sheer volume of water overwhelms these natural conduits, leading to widespread flooding and affecting the landscapes through which they course. Across different seasons, Varying temperatures give rise to diverse atmospheric conditions, influencing wind patterns and precipitation. For instance, during winter, the air over the ocean may be warmer than that over the land. This temperature contrast prompts wind flow from the land to the sea. In contrast, the summer season sees the land heating up, causing the air over it to become warmer than the ocean air. This temperature shift reverses wind currents, carrying moisture-laden air from the ocean and depositing it over the land. The monsoon wind system is like a climatic dance, choreographed by seasonal changes that dictate the direction of prevailing winds. This dance can bring intense rainfall, completely transforming the usual weather experienced throughout the year. Imagine regions used to a dry season suddenly drenched in heavy rains during the monsoon, completely changing the regular weather patterns and flooding the landscapes. But monsoon flooding isn't just about rainfall. In some areas, snow thawing adds to the excess water, making the flooding even more challenging. Picture this. As the snow melts, it becomes part of the factors contributing to the seasonal ebb and flow of water. So, it's not only rain, but also the gradual thawing of snow that plays a role in shaping the impact of monsoon flooding in different regions. Many years ago, something interesting used to occur with the Nile River in Egypt during the summer. When it rained a lot at the beginning of the river, the water would spread out, making the river much wider. What's surprising is that this regular flooding wasn't a problem at all. It was actually fantastic. The rising water left soil full of nutrients along the riverbanks, turning the area into excellent farmland once the water went back down. This flooding was crucial for civilization's thrive in the dry Egyptian desert. But things have changed now. There's a dam that manages the river, storing up the rain from the summer and letting it out slowly. This dam has made it possible for Egyptian farms to grow crops throughout the entire year. Floods can also happen when the ocean goes farther into the land than usual, often because of unusual tidal activity. This tidal flooding might happen because of specific wind patterns or large ocean waves called tsunamis, which are caused by a shift in the Earth's crust. How bad a flood gets depends on how much water gathers at a particular time and how well the land can handle it. One important thing is the size of rivers and streams in an area, but another crucial factor is how well the land can soak up water. Think of soil like a sponge. When it rains, it soaks up water, but when it can't soak up anymore, the extra water has to flow away. Interesting, right? Various materials soak up water at different speeds. To see this in action, try taking a bucket of water outside and dampening multiple surfaces. Picture the soil in a forest as a fantastic sponge. Pour several buckets of water on it, and it eagerly drinks everything. Rocks, however, seem to repel water, not absorbing any. Hard clay falls in between. It takes in some water, but not as much as soil. Generally, cultivated soil for farming isn't as thirsty as untouched land, but areas used for agriculture might be more susceptible to flooding. Concrete, on the other hand, is among the least absorbent surfaces when it comes to water. Environmentalists are still studying the situation in California to predict if another flood will hit the coasts sooner than we think. Still, in the meantime, they are trying to salvage what they can of the ruins and calm surrounding residents down. Did you enjoy watching this video? Leave a comment on your thoughts about the recent California floods. Don't forget to hit the like button, share the video with everyone, and subscribe to our channel.